All right, now here we're going to be finding the length of a segment from its endpoints. All we have are the endpoints. We don't have a drawing anymore. One thing you could do is you could actually graph these out and then do the Pythagorean theorem thing, but that'd be a little awkward. There's an easier way. Okay. One thing, let's just make a little sketch over here. If you want to find, if I have say a point here and a point here, and I want to find out what my, what the two legs of that right triangle are going to be. Notice that the length of this leg is just, say this was, I don't know, for example, I'll do this as 4, 5, right? And this point down here, let's call it, I don't know, 6, 1. Okay. Notice that this y coordinate right here is a 1, and this y coordinate is a 5. And this tells you this point is one space above the axis, and this one, y coordinate 5, tells you this coordinate is 5 spaces above the axis. So the difference between them would be 5 minus 1, or 4. So this is 4 spaces between them. You can tell that by subtracting the one y coordinate from the other. And for the x coordinates, well, this 4 means that we are 4 spaces away from the axis here, and the 6 tells us that we're 6 spaces away from the axis. So the difference between those is 2. 6 minus 4 is 2. Now, the one kind of problem with this is that you'd have to know what order to subtract them in for a lot of applications. But in this particular case, you don't, because if I subtract 6 minus 4, I get 2. Or I subtract 4 minus 6, I get negative 2. And either way, when I put it into the Pythagorean theorem, I'm going to square it. So it really doesn't matter what order I subtract in. One's going to give me a positive, the other's going to give me a negative. But when I square them, either way, I end up with a positive number. Okay? So what we're going to do is we're going to call this our A, and we're going to call this our B. So the horizontal distance, how far apart the 2 points are, we get that from subtracting one x coordinate from the other, and that's going to be our A. And then our vertical distance, how far apart they are, we're going to call that our B, and that's just what we get by subtracting one y coordinate from the other. Let's take a look. Okay. So I've got x and y and x and y. So A is going to be 0, or negative 2 minus 0, let's call that. Negative 2 minus 0, which is negative 2, and B is going to be negative 7 minus 2, which is going to be negative 9. Now, it's not necessary for you to subtract in the same order. Notice I went negative 7 minus 2 and negative 2 minus 0. It's not necessary, but it's a good habit to get into, because there are some cases where it is necessary to do it that way. All right, so I got negative 2 and negative 9. So I've got negative 2 squared plus negative 9 squared equals c squared. That's 4 plus 81 is c squared. That's 85 equals c squared. So square root of 85 equals c. Let's see if we can, 85 is not divisible by any of our square numbers, so I don't think it can be simplified. One thing I want to watch out for is oftentimes students will punch this into their calculator and they get negative 4. Because the calculator, if you punch it in and if you type in negative 2 squared, it follows the order of operations and it squares it and then it makes it negative. It does the exponent first. So this would give you a negative 4. But that's not what you want. You want it to multiply a negative 2 times another negative 2, which would be a positive 4. 2 negatives multiplied together make a positive. And so you have to put parentheses around it if you're doing it in the calculator. Or you could just remember that if you get a negative answer when you square something, then you've probably made a mistake somewhere along the line, because square numbers are always positive. Okay, let's look here. So xy, A equals negative 1 minus negative 4, which is the same as negative 1 plus positive 4, which is 3. B equals 2 minus 8, which is negative 6. 3 squared plus negative 6 squared is c squared. 9 plus 36 is c squared. 40 plus is c squared is c. In this particular case, 45, that can be reduced because 45 is square root of 9 times square root of 5, which is c squared, and that's just 3. Again, so if you can break down a number into the product of a square number and then some other number, then that square root can be reduced just by breaking it apart and noticing what square root of 9 is just 3. Alright, let's take a look at another one here. We've got A is going to be x, y, x, y. We've got 7 minus negative 2. And B is going to be negative 7 minus 4. 7 minus negative 2 is 9. And negative 7 minus 4 is negative 11. So 9 squared plus negative 11 squared is c squared. 81 plus 121 is c squared. And 81, 121, that's going to be 202 is c squared. That's square root of 202. Let's say that's 101 times 2. I don't think that can be reduced. Simplified. So we're good there. Oh. Okay. Let's see. Got x, y, x, y. A equals negative 6 minus negative 3. B equals 6 minus 3. That's 3. And that is negative 3. So we've got negative 3 squared plus 3 squared is c squared. 9 plus 9 is c squared. 18 is c squared. Square root of 18 is c. And that is the square root of 9 times the square root of 2, which is square root of 3 times 2. I'm going to simplify it. Alright, next up we have, see, x, y, x, y. A equals negative 4 minus negative 8. B equals 0 minus 4. That's a negative 4. Negative 4 minus a negative 8 is a positive 4. So I have 4 squared plus negative 4 squared equals c squared. That's 16 plus 16, c squared. 32 equals c squared. Square root of 32 is c. And 32 is 16 times 2, which is 4 times the square root of 2. Because you can break 32 down into 16 times 2. So square root of 32 is square root of 16 times square root of 2. And square root of 16 is just 4. Alright. X, y, x, y. So we've got A is negative 8 minus 6, which is negative 14. And B is negative 7 minus negative 3, which is negative 4. So I've got negative 14 squared plus negative 4 squared. This is 196 plus 16. And that is 212. Yeah. So square root of 212. See, can that be simplified at all? Let's see. 212 divided by 2. 106 divided by 2. 53. I think 53 is prime. So that's 4 times 53. So that becomes square root of 4 times square root of 53. And square root of 4 is just 2. Alright. Let's do some more. See, we've got x, y, x, y. I've got a is 3 minus 0, which is 3. B, 6 minus negative 3, which is 9. So 3 squared plus 9 squared is c squared. 9 plus 81 is c squared. 90 equals c squared equals c. It's 40. That's 9 times 10. We'll see. It's 3. Okay. Next door. We have a equals negative 6 minus 3, which is negative 9. B equals 3 minus 5, which is negative 2. Negative 9 squared plus negative 2 squared equals c squared. 81 plus 4 equals c squared. 85 is c squared. And square root of 85 is c. And I don't think that can be simplified. What's 5 times 17? No, can't be simplified. Okay, here we've got a equals 8 minus negative 8, which is 16. And b is 7 minus negative 7, which is 14. So we've got 16 squared plus 14 squared is c squared. That's, 16 squared is 256 plus 196 is c squared. Well, let's see. Well, if that was 200, that'd be 456. Take away 4, 452 equals c squared. So the square root of 452 is c. See if we can simplify that. 452 divided by 2 is 226. Divided by 2 is 113. I don't think 113 can be, that might be prime. So this would end up being 4 times 113. So this would be, we'll see, and that's 2. There we go. Alright, next door here. So we have a is 2 minus 2, which is 0. Negative 3 minus 5 equals negative 8. Now notice that this point right here, over 2, up, down 3, over 2, down 3, over 2, down 5, or up 5, those 2 points are right on top of each other. So this is a straight up and down segment. So then the difference between the 2 points is just 8. But we'll do the math out and you'll see. So I've got 0 squared plus negative 8 squared is c squared. That's 0 plus 64 is c squared. And the square root of 64 is 8 equals c. So pretty straightforward there. Alright, down here we've got a equals negative 5 minus 4, which is negative 9. B equals 2 minus negative 4, which is 6. So I have 9 squared, well, technically negative 9, plus 6 squared equals c squared. That's 81 plus 36 is c squared. And that's 117 equals c squared. And 117 is, that's a multiple of 9. It is, let's see, 117, 120 divided by 3, 40, 39, 13. It's 9 times 13. Equals c. So that's just 3 times the square root of 13. Okay. All right, one more. So we have A, 7 minus negative 1, see which is 8. And then I've got B, negative 8 minus 4, which is negative 12. So I have 8 squared plus 12 squared. Well, it should be negative 12 squared, but it doesn't really matter. Equals C squared. 64 plus 144 is C squared. And that would be 208 equals C squared. 208 equals C. So let's see if we can break this down. 208 is divisible by 2, giving us 104. Divisible by 2, giving us 52. Divisible by 2, giving us 26. Divisible by 2, giving us 13. So it works out to be 16 times 13. So I got square root of 16. Square root of 13, and that just works out to 4 times the square root of 13. All right. So just to recap how we're doing this, we're just using Pythagorean theorem to find the lengths of the legs. I just have to find how far apart they are horizontally. That's just one x coordinate minus the other, and then I have to find out how far apart they are vertically, and that's just one y coordinate minus the other, and that's our A and our B. And I just called the horizontal distance A and the vertical distance B. Doesn't really matter because you can switch A and B around. And then plug them into Pythagorean theorem. And the tricky part is going to be telling whether you can simplify the radical or not. So I tell you what you do is, I mean, if your answer doesn't match what the, like if you have a non-simplified radical and the answer key has a simplified radical, one thing you could do is you could punch them both into the calculator and see what they are as a decimal. And if they match, then they're the same number. You have the right answer. All right. Good luck with all that.